All right, friends, welcome back. We're going to learn about segment addition postulate and angle addition postulate today. We're going to talk about what they are, what they mean. We're going to do a few examples, and then we'll be on our way. The word, the name kind of tells you exactly what it does. Segment addition. We're going to be adding segments. So remember that a segment is a piece of a line. So if I have like A, B, C, and D, those are points on a line. Remember, the line goes forever technically, but segment addition has to do with the segments. For instance, for this figure here, I could say that AB plus BC plus CD, if I add those up, let's look at them real quick. Actually, let me color code them a little bit better. AB plus BC plus CD. Well, CD is the segment that starts at C and goes to D. BC starts at B and goes to C. And AB starts at A and goes to B. If you combine all of those things, you get the entire segment from A all the way to D. And that, my friends, is the segment addition postulate. That's it. All it says is if you add up the small segments, if they're connected on the same line, that you're going to add up and equal the whole thing. Another example would be, I could say AB plus BC. If I stop right there, what is AB plus BC? It's a little different. AB plus BC would stop at C. That equals A to C. So segment addition postulate, the smaller segments, as long as they're in a line together, they add up to the whole thing. Let's plug some numbers in there just so we can kind of play with it a little bit. If I told you that AB equals 10, BC equals 12, and CD equals 8, I'm just making numbers up, we would know that AB would be 10, BC would be 12, CD would be 8. We add those together. That means AD, the entire thing, would have to be 30 units long. Plug in 10 plus 12, A to C, that is 22 units long. Boom, that's all there is to it. Angle addition postulate is very similar to that, and I'm going to shorthand that AAP, angle addition postulate. Remember that angles are made with rays. So we have two rays. And right now there's only the one angle, so there's not much of an angle addition postulate right now. But if I threw another ray in here, how many angles do you see? Well, let's play with it. This is one angle, two angles, and the whole thing would be the third angle. There's actually three angles in this picture right now. And what I'm telling you is that the measure of angle 1 plus the measure of angle 2, when you add those together, have to equal the measure of angle 3. Remember, we can add measurements. We can't add shapes. I wouldn't say angle 1 plus angle 2. It's their measure. So putting some numbers on there. Let's say that angle 1 here was 30 degrees. And angle 2 here is 40 degrees. I'm just totally making some stuff up. We could say angle 1, 30 degrees, plus angle 2, 40 degrees. The entire thing would have to be 70 degrees. So it's the same idea, segment addition postulate, angle addition postulate. We're adding angles to equal the whole thing. Up here, we were adding segments to equal the whole thing. Another word that we need to be familiar with is the word bisector. Bi meaning two, sector meaning sections. Two sections, and as a matter of fact, they are two equal sections. So a bisector is two equal sections. So let's say that we have an angle here. And we'll name this angle A, B, and C. What would a bisector do? A bisector, what do you think it does? Two equal sections. So if I had a third ray, and we'll put a D here, and if I said ray BD is a bisector, what does that mean? It means it cuts the angle, cuts the big angle, angle ABC, into two smaller equal angles. So in this case, we would know, like, if this was 20 degrees, that this is also 20 degrees. I'm just making numbers up, but they'd have to be the same size. They would have to be the same size. Hopefully we're feeling pretty good about that. So here's some examples that we would do with segments and angles. Let's do a segment example. We have like A, B, and C. And let's pretend they say that AB equals 10, BC equals 2x plus 7, and they tell us that AC and AC equals 8x minus 20. Totally making it up, just making some stuff up. So let's see what that would look like. A to B, we're saying that this length is 10. B to C, this length is 2x plus 7. And A to C, the entire thing, is 8x minus 20. We know from the original picture that AB plus BC has to equal AC. So let's plug in what they gave us. AB is 10. BC is 2x plus 7. That has to equal 8x minus 20. And now that's an Algebra 1 equation that we can solve. So I would move over the 2x. This would become 6x. I would add 20, so 20, 37. Divide by 6, so x equals 37 over 6. So how long are the individual pieces? Well, AB, they told us, equals 10. How about BC? We would have to plug that in. That would be 2 times 37 over 6 plus 7. For right now, you can just type these in the calculator, but I would love for you to get good at this. How do you solve that? How do you fix this? Well, you reduce. 2 and 6 reduces to 1/3. So really, we have 37 thirds plus 7. We need a common denominator, so 37 thirds plus 7 times 3 is 21 thirds. So BC would equal 58 thirds. Whoop. And I'll change color so we can see it, but I'm going to do the same thing with AC. AC would equal 8 times 37 over 6 minus 20. 8 and 6, take out a 2. That reduces to 3 and 4. Multiply the top, be 120 plus 28. Be 148 over 3 minus 20, which is 148 over 3. 20 times 3 is 60, so it'd be 60 thirds. Minus 48 minus 12 would be 88 thirds. So kind of running out of room, but AC would equal 88 thirds. Again, you can just type those in your calculator if you need to. But that would be your 3 answers. AB equals 10, BC equals 58 thirds, and AC equals 88 thirds. Boom. Love it. A similar situation with angles. So let's say we have an angle here, and we have another ray, and let's say that this is ray AB. So ray AB is a bisector. Okay. And let's say that we have, let's put some other letters, C and D. So let's say they tell you the measure of angle CAB equals 4x plus 6, and the measure of angle CAD equals 10x minus 12. All right. So if that's what we knew, could we fill out each individual angle here? All right, let's see. Because AB is a bisector, I know that these are the same size. So I know that this is 4x plus 6. I know that this is 4x plus 6. And then they tell me the whole thing. I know the whole thing is 10x minus 12. Oh, let me change that because that's going to be a problem. No, it's not. No, it's not. No, it's not. We're good. We're good. Okay. So what do we know? We know that if you add the two small ones, so 4x plus 6 plus 4x plus 6, they have to add up to the whole thing. Well, the whole thing is 10x minus 12. And now that's an algebra 1 equation. This would be 8x plus 12 equals 10x minus 12. So 2x equals 24. This time x is a nice whole number. X equals 12. I don't want to take the time right now, but you would plug those back in. All right. Let's do a few more examples here, guys, and then we'll be done with this video. You don't, if you're feeling good, you don't have to watch. But every little time you see something, maybe there's something different going on. I'm just going to do a few problems off the worksheet that we had in class. ZTU is x plus 91. I'm going to change the size here. That's x plus 91. STU, that's the whole thing, is 160. And STZ is x plus 71. So part plus part equals whole. X plus 91 plus x plus 71 equals 160. So 2x, 91 plus 71. 90 plus 70 is 160. That'd be plus 162 equals 160. So 2x equals negative 2. X equals negative 1. Find x. That's actually all we're doing, so we're done. It's always good to check your work, though. If I plug in negative 1, negative 1 plus 91, that would be 90. Negative 1 plus 71, that would be 70. 90 plus 70, does that equal 160? Yes, we're good. Next question. It says PS equals that, SQ equals that. Is S the midpoint of line segment PQ? I need to draw this out. P, Q, and it says, is S the midpoint? So we don't know if it's the midpoint or not. I'm not going to put it in the middle. Maybe it's the middle, maybe it's not. But if I put it there, I might confuse myself. I know PS is 3x plus 2. I know SQ is 4x minus 5. And I know that PQ is 39. So I don't know if S is the midpoint. I don't know. I'm not going to pretend that it is. If you pretend that it is, you're going to mess yourself up pretty bad. I don't want you to get messed up. Don't get messed up. But what are the things we do know? We know for sure that PS plus SQ has to equal PQ. That's true. That is segment addition postulate. So let's solve. 3x plus 2, that's PS. 4x minus 5, that's SQ, has to equal 39. That has to be true. So 7x minus 3 has to equal 39. So 7x has to equal 42. X has to equal 6. Plug it in. 3 times 6 plus 2, that's 18 plus 2, that's 20. I already know S is not the midpoint. The whole thing's 39. Is 20 half of 39? No. But let's just check our work. Let's plug it in over here. X equals 6, so let's plug it in. 4 times 6 minus 5. That's 24 minus 5, that's 19. So 20 plus 19 is 39. That checks out. So we know we did it right. But does 20 equal 19? No. So S is not the midpoint. Is S the midpoint? No. No, no, no. Points A, B, and C are collinear. B is between A and C. So I'm going to draw that out. A and C. And it just says it's between. Does that mean it's in the middle? No. They give us AC. They give us AB. And they give us BC. Very much like the last time. So AC, the whole thing is 3x plus 3. AB is -1 plus 2x, and BC is 11. So I'm going to do part plus part, -1 plus 2x plus 11. Those two parts have to add up to the whole thing. That's my setup. We can solve this. This would be 2x plus 10 equals 3x plus 3. X has to equal 7. Let's plug in 7. That's our answer. That's all they asked for. But let's test it out. This would be -1 plus 2 times 7. That would be 14 minus 1. That's 13. This would be 3 times 7 plus 3. That would be 21 plus 3. That would be 24. 13 plus 11, right? 13 plus 11. Does that equal 24? Yes. We just confirmed we got it right. All right. That's the last one. I'm going to work with you there. Hopefully you learned something. Hopefully you're doing a good job. I'll see you next time.